Okay, today we're going to be looking at compound events. That'll be, we'll find probability of compound events. We'll look at finding, looking at the sample space to find the total number of outcomes. So we will use lists, we will use tree diagrams. So to get started, the essential question, how do you find the probability of a compound event? A compound event consists of two or more single events. To find the probability, you write a ratio of the number of ways the compound event can happen to the total number of possible outcomes. The sample space, in this case, of an experiment is the set of all possible outcomes, and today we're going to look at finding the sample space for an experiment, and we'll use tables, lists, and diagrams. So in the first example, we're going to use a table. This could be very similar to looking at all the different ways that we could roll the sum of two dice, just like when we play the game Skunk. So Jacob rolls two fair number cubes. When you find you are going to find the probability that the sum of the numbers he rolls is 8. So we're going to use the table first to find the sample space for rolling a particular sum. So why don't you start filling out the table? So what it's basically doing is if you roll two ones, the sum is a 2, right? Because we're talking about for rolling a particular sum. This word right here tells us that we're adding the two numbers together. So we just have a lot of information to fill in. And you're going to see some patterns emerging. Okay, so you can kind of look at, it's kind of neat to look at, like at any diagonal and see that the patterns, you know, that in diagonal, horizontal alignment, the sums are all the same, that there is one outcome of 2 and one outcome of 12, and then you can see which one has the highest probability of being rolled. Carly?
7.
Yeah. That is the most outcomes, so that is definitely in rolling two number cubes the highest probable outcome. Okay, so we first want to find the possible outcomes that are in the sample space. So how many total outcomes do we have all together? So to answer part B, how many possible outcomes, you simply count up all of the numbers you filled in, and we get 36. If we circle the outcomes that have a sum of 8, so you can circle the 8s. Okay? Those, in this case, are the favorable outcomes because that's what was asked in the original question. Then how many ways can he roll the sum of 8? And you count them. The answer is 5. So the probability of rolling a sum of 8 is the favorable outcomes out of the total possible. Okay, let's continue and try this. Let's look at the table that we just had in the previous example, and it should be on your papers, to find the probability of rolling a sum less than 5 and rolling a sum of 7 or a sum of 9. Okay, for rolling a sum less than 5, we are not including 5, so you count all the 4s, all the 3s, and that one and only 2. Hold on a second. Okay, so for 1A, we would have 6 favorable out of 36, and remember we want to express this in lowest terms, so we would have a 1 out of 6 probability. And for part B, rolling a 7 or a 9, in this case that means we're going to add them together, the probability of a 7 and the probability of a 9. Together add all the 7s and 9s, and you would get a 10 out of 36, which would simplify to 5 out of 18 for our probability. So we want to give an example of an event that is more likely than rolling a sum of 8. So if you look at your table, you can find an example that is more likely than the original probability that we found for 8, which was 5 out of 36. So which one is has a probability that is more likely than 5 out of 36? Okay, so looking at reflecting on 1C, it could be that rolling a 7 would be more likely than rolling an 8. In fact, it would be the only one more likely. So rolling a 7. And an example of an event less likely than rolling an 8, it could be rolling a 4, rolling a 12. Any of those type of things would fit because it would be less likely. So rolling a sum of 12. So we are going to complete the tree diagram to find the sample space for this compound event. So let's get the tree diagram in our field of view here. Okay. So when we look at the first one, so now we know we have 2 different types of bread. We have white or wheat. This is the first event, is selecting the bread. The second event is the meat. So our choices that we are given are ham, turkey, or chicken. So up here, only one of them is missing. And down here, they're all missing. So fill them in: ham, turkey, or chicken. And then the types of cheeses is our third event. So when you're looking at tree diagrams, you're kind of trying to realize how many different branches you're going to go out to make. So always separate them out by, what is my first event? What choice do I have to make first? In this case, it's the bread. Then second choice is the meat. And third, the cheese has to come off of each individual thing. So for here, we'll have a cheddar and a Swiss for each. Cheddar and a Swiss. So the first part is going to ask us how many total possible outcomes we have. Okay. So our total possible outcomes can be found by counting the very last branch on the tree, which in this case represents the cheese. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 total outcomes. And in this case, the favorable outcome would be picking wheat, turkey, and Swiss, which represents 1 of the 12 possible outcomes. So our probability is 1 out of 12. So going down, looking at the reflection on this one, how can you find the probability of choosing a sandwich at random that is on wheat bread for part A? Okay, so to find the probability of choosing a sandwich at random that is on wheat bread, you count up all the possible outcomes, which are still 12, then count all the possibilities of getting wheat, which equals 6. So if there is 6 out of 12 chances of getting a sandwich on wheat, you would simply write 1 out of 2 because you would reduce that down. To find the probability of choosing a sandwich at random that does not have ham, you need to count all the outcomes that do not include ham. Since there are 4 outcomes with ham, there are 8 outcomes without, and there are 8 out of 12. And if you divide both by 4, you will get 2/3 of the outcomes that do not have ham. In example 3, we're going to use a list to find some compound events. So when a person opens a new account at Joe's bank, he or she is randomly assigned a temporary PIN. The PIN is a 3-digit security code that uses the digits 5, 6, or 7. Any of these numbers may be repeated. Find the probability that Joe's temporary PIN is 777. So sometimes we want to make an organized list to find the sample space, and this is what you're going to do. First, list all the PINs that start with a 5 and have 5 as the second digit. Fill in the third digit with all the possibilities. Then list all the PINs that have 5 but have 6 as a second digit. Then next, all the PINs that start with 5 and have 7 as the second digit. Fill in the third digit for all of them. Now that you've made the list with the 5s, repeat steps A through C and starting with 6. Then repeat A through C for the pin starting with 7. So I'll give you a little bit of time to get those filled in. Okay, so if you look at each, we've filled it out following their directions. Look at each line right here. So this is a pin number, 555. So for this whole first grid with 5 first and 5 seconds, there are 3 pins. Since there are 9 grids, we have a total of 27 outcomes. And if you're looking at the probability that Joe's temporary pin is 777, it would be 1 out of 27. Finally, you can calculate the probability that Joe's pin would include at least 1 5. So if you look at your sample space above, you could count up at all the pin numbers that have at least 1 5. And out of the 27 possible, 19 of them have at least 1 5. So the favorable outcomes would be 19 out of 27, and they share no common factors, so we cannot reduce. For 3B, what is the probability that Joe's pin includes at least, or exactly, here's the key word, exactly 2 6s. So again, count up all the ones at the top that have exactly 2 6s, and you will find that that is 6 out of the 27, which will reduce down to 2 out of 9.